Lesson 3 of Unit 3. This is an application 1, interpreting remainders. We're going to be able to apply our knowledge, our understanding of fractions and division to report remainders as fractions. In previous unit, we decided whether or not we would round up or we would ignore remainders. Now we're going to be understanding them reporting them as fractions as well. We're going to perform operations with multi-digit whole numbers and with decimals to the hundredths. We're going to apply and extend previous understandings of multiplication and division. Let's warm up. So it says to answer the following questions using extended division facts to assist you. So our first one says, how many 7s are in 490? Second one is, how many 70s are in 4,900? And then how many 700s are in 49,000? So pause, think about it, and come back. Okay, so we know that there are 7 7s in 49, so there should be 70 7s in 490. We know there are 7 7s in 49. We know there are 70 7s in 490. So there should be 70 70s in 4,900. And then we move on. There should be 70 700s. Let's go ahead and write this one out. So if we do 70 700s, we know 7 and 7 is 49. And then we add 1, 2, 3 zeros. 1, 2, 3, giving us 49,000. Again, this is just to warm you up. Should be a review. Mr. Bergener has 30 yards of masking tape for a tower building contest. There are 7 teams, and each team needs as much tape as possible to build the tallest tower. They need as much as he can give them. Okay? He's obviously going to give each team the same amount. It wouldn't be fair if he gave, team A 15 yards and the other teams dividing up that last 15. So Anna says that each team should get 4 yards of tape because 30 divided by 7 is 4, remainder 2. Do you agree that the remainder should be ignored? Why? Or why not? Think about it. When we look back up here, the teams need as much tape as possible. Can we divide tape up and give it all away? Or do we have to just stop and say, okay, this is what's left over, you don't get it. We can't split this up. Okay, we solved fair share problems like this in the previous lessons. We knew that 2 divided by 7 is the same as writing 2 over 7, which give us 2 divided by 7 is 2 sevenths, a fraction, right? So if I come back to one like this, and I see that we have 4 with a remainder of 2, and there are 7 teams, we're taking 2 yards divided by 7 teams, we can get a fraction of 2 sevenths. So if that 2 extra yards is divided evenly among 7 teams, how much tape will each team receive? How much tape does each team receive in total when the entire rule is used? Okay, so we're going to apply that understanding of fractions and division to report remainders as fractions. So when we go back up to this, her answer is wrong. In fact, each team should get 4 and 2 sevenths yards, because we are going to report this remainder as a fraction, because we can and will split up that extra tape evenly amongst the teams. No one said that it had to be in a whole number. Okay? So again, we're going to apply our understanding of fractions and division and report those remainders as fractions. So let's look at Ben. He just adopted a dog. And as we're doing these, we're going to remember to draw pictures, or if you want those fraction circles, Pictures, though, are really going to help us out as we move forward because we're going to have those remainders. We also can use partial quotients division as needed to help us solve. So Ben adopted that dog. The veterinarian said a bag of dog food should last 14 days. The bag contains 21 cups of food. If Ben feeds his dog the same amount each day, how many cups of food should he feed the dog? So I want you to pause and think about this. One bag should last 14 days. The bag contains 21 cups of food. So we're saying 21 cups of food divided up evenly among 14 days. Okay? So first, you're going to divide 21 by 14 because remember we said that 21 equals that one bag. You're going to get 1 remainder 7. Okay? Because 14 can only go into 21 one time and you have 7 left over. Then think about dividing that remainder 7 into 14 days. Okay? 14 equal parts. 7 divided by 14 equals 7/14. So your answer to this is that Ben should feed his dog 1 7/14 cups each day. The number model is 21 divided by 14 equals 1 7/14. Okay? Because what you're doing here is you're taking that 7 and you're dividing it by 14 days. That's how we know that where that 14 comes from. Let's look at another one. Jenna's at an amusement park with her younger brother. One of the rides has a sign saying the minimum height to ride is 54 inches. Jenna knows that her brother is 3.5 feet tall. What's the ride's height requirement in feet? How can we figure that out? What do we need to know? You're right. We need to know that 12 inches equals 1 foot. Okay? So if we know that 12 inches equals 1 foot, we're going to see that 54 divided by 12 is 4, remainder 6. Okay? So he's 4 feet with 6 inches left over. Then think about dividing that remainder 6 into 12 parts because we know 12 equals the 1 foot. So if we turn 54 inches into feet, you have to be 4 feet and 6/12, 4 and 6/12 feet tall, or 4.5 feet because we know 6 is half of 12. That number model is 54 divided by 12 because we need to be 54 inches, dividing it by 12 inches because 12 inches equals 1 foot. So is Jenna's brother tall enough to go on the ride? What do you think? I'm going to say no because he's only 3.5 feet. You have to be 4 and 6/12. Nope. 3.5 feet is less than 6.5. 4 and 6/12. Oh my goodness. So if we can simplify a fraction, we should do that. Okay. So here are some examples. 1 7/14 should be reduced or simplified down to 1 1/2. 3 6/8 would be reduced down to 3 3/4. 2 25/30, 2 5/6. Notice these are easier mixed numbers to work with. Mixed numbers should be reviewed from lesson 2. So examine these pairs of number models and describe the pattern we notice. Okay, so if we look at this one to this one, I see that 21 divided by 14 is 1 with a remainder of 7. When I look over here, I see it's 1 7/14. Here we have the remainder. Here we have what we're being divided by. So here's the numerator. Here's the denominator. So if we're going to use that same pattern, this should be the numerator. This should be the denominator. And what do we see? Numerator, denominator. 1 15/20. So again, here, 54 divided by 12 was 4 with a remainder of 6. So how many parts did we divide it up into? 12. So we got 4 6/12. Now, we know that we just said that this can be reduced. So 7/14, 7 is a half of 14. 15/20, we can divide both of those by 5. 15 divided by 5 is 3. And 20 divided by 5 is 4. And then this one, we know 6 is half of 12. So that would be where we get those. So now it's your turn. You're going to turn to page 77 and 78. We're going to do one of these together. Don't worry. But there's 4 problems here. And I want you to see that there's the number story. You need to do a number model. You need to figure out, we've done these similar when we were doing our division, where you find the quotient and the remainder. But now you'll notice that there's not just round it up and ignore it. Now we've added a third one that says reported as a fraction. So I'm going to do number 1. I want you to follow along, and then I want you to pause the video and then do 2, 3, and 4. So Rebecca and her 2 sisters made pancakes for breakfast. They made 16 pancakes for 5 people. They want to make sure each person gets an equal serving. How many pancakes will each person get? So let me grab this. I see that we're talking about Rebecca and her 2 sisters here. That's 3. I don't need that number though. I see that they made 16 pancakes for 5 people. So I want to go back and think. We're taking 16 pancakes divided by 5 people. Okay? So again, the question is, how many pancakes will each person get? So I'm going to draw a picture for this. And I'm going to do 16 pancakes here. So you'll notice that I'm going to do 4 groups of 4. Okay? So now I'm going to divide it into groups of 5. So I'm going to do, here's a group of 5. Each person gets 1 there. Here's a group of 5. And then here's a group of 5. And then there's a pancake left over. So in here, I know that this is going to be person 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. And then we've got this 1 pancake left over. So I see that 16 divided by 5 is 1, 2, 3. Each person gets 3 with a remainder of 1. Okay? So down here, what I would do is I'm going to say the quotient is 3, remainder 1. But I want to decide how many pancakes will each person get. Do I ignore it, report as a fraction, or round it up? Well, I know that I'm talking about a pancake. And if you've never had a pancake, you can cut a pancake up. You can share a pancake. And I know that there's 5 people. So what I can do is I can split this up. Ooh, hopefully I would cut that better in real life. But I can split that up amongst 5 people. There's person 1, 2, 3, 4, and 5. So I can see that actually each person's going to get 3 and 1/5 of a pancake. And so I'm going to actually report it as a fraction because I can cut up a pancake. I can share that. It's not like in the past when we were, buying a pair of pants and we only had $5 left over for $15 pair of pants. We can split up these pancakes. And that would be my Y right there, what I just said. That's what you would write right there. So let's click and see what they said. Check my work here. So again, the number model is 16 divided by 5 equals P for pancake. Here's their thinking. They know 3 times 5 is 15. And I kind of did that here with my picture. And so 16 divided by 5 would be 3, remainder 1. And then you can see their leftover pancake. Let me clear out my ink here. And you can see that they had 3, remainder 1, 3 and 1/5. And pancakes can be cut into smaller pieces. Okay, so now you're going to read about Lewis's soccer team. You're going to read about Mariana and her $80 from babysitting, and Jeremy reading 100 books by the end of summer. Go ahead, solve 2, 3, and 4. Remember to show all of your work, come back and check. Okay, let's look at number 2. We see that the number model should be 32 divided by 6 equals, they said, C. And you can see that they drew out groups of 6 bottles because there was a carrier, okay? And each carrier would hold 6 bottles. Now, they took 32 divided by 6, and they got 5 with a remainder of 2. Because I know that 6 times 5 is 30, and then you would have 2 left over. Well, Lewis's team actually needs 6 carriers, and you need to round up the quotient because you cannot cut a carrier in half. You can't only break off 2 of the things for the bottles. So you just need another carrier for those 2 leftover bottles. Remember, you got to also ask yourself, is my answer logical? Is it reasonable? And so if you were to say, oh, I'm going to report as a fraction, you need to ask yourself, well, is it reasonable that I would only take part of a carrier? If by having these conversations you think, oh, I need to pause and rethink my work, go ahead and do that. But you'll see here on 3, we took the $80 from babysitting and divided it by $17 to see how much shirts and pants she can buy. This one, they decided to actually just show a division problem. 80 divided by 17. And you'll see is 4 with a remainder of 12. And she can only buy 4 items. She has to ignore that remainder. And again, why? Because she doesn't have enough money left over to buy another pair. We can't say, oh, well, I'll just buy a pant leg, or, oh, I'll buy half of a shirt. She has to have enough money. So she would definitely ignore it. She'd save that $12 for the next time. And then Jeremy with those books. So he's going to do 100 books divided by 36 weeks. And they just did the division here. 100 divided by 36 is 2. And then we have 28 left over, which is 28 books divided by 36. So you'll see that the quotient is 2 with a remainder of 28. Jeremy needs to read 2 and 28 36 books. So we're going to report as a fraction because it makes sense. It's logical. Jeremy can read part of a book. So each week he needs to read 2 books plus 28 36 of a book. So he needs to read almost 3 books there. But we're not going to round it up. We're just going to do a fraction there. All right. That was an application lesson, interpreting remainders, reporting them as fractions, ignoring them, or rounding up.